DIY digital dash for 200 bucks. No more spending $2,000 on digital dashes. You don't need standalone, you don't need canbus, but this will work with both if you do have it. All you need are some sensors. The gauge sensors that you probably already have for the gauges in your car. Let's go through how to do this for $200. So why would you do this? Well, I had so many gauges in my car. So essentially I'm getting rid of 8 gauges here. The entire gauge cluster. A triple gauge pod with boost, oil temp, oil pressure, and then a coolant temperature gauge as well, just separately. And we're changing that out for an Arduino, a Raspberry Pi, and a 7-inch touchscreen. Let's get started. Okay, so I have this items needed list. We'll go through this one by one. This is all in the description. Let's go through this. So the first is the Raspberry Pi here. This is going to be about $75. This is just the Raspberry Pi 5 4 gig model. You can get more gigabytes. I wouldn't suggest less though, and a Raspberry Pi 5 is definitely what you want because you want that kind of better processor that the Pi 5 comes with. Then next we have the 7-inch touchscreen. This is pretty cheap. You don't need a 7-inch. You can go with a 5-inch. You can go with a 10-inch. You can go with a 120-inch screen. This was just the option that I wanted because I didn't really need a lot of data displayed. I didn't need it huge. So I kept it kind of cheap and kept it at 7 inches. The next is going to be the Arduino. So this is going to be the Arduino Mega R3 board. It's 2560. It comes with a USB cable. This is only $22. Pretty cheap. Maybe buy 2 of them because you may blow the first one. I did. And buy a second one. So next are these. A pair of these is 2-pack of these 12 volt to 20 or 5 volt step downs. And this basically allows you to connect your Raspberry Pi and or your Arduino to your car, to your battery. So I get to, I power them separately. So the Raspberry Pi has power and the digital dash, or excuse me, the Arduino has its own power as well. And the reason I do that is because I don't want signal interference. If you power the Arduino from the Raspberry Pi using the USB, you will get like chatter because it's sending data and it's sending power through that line, and you don't want to do that. You just want to send data through it. The next would be these female jumper pins, or these male-to-male jumper pins. It comes with female ones as well, but you're basically going to be using just the male-to-male. And we're going to be cutting those to length and using those. This makes it really easy to connect the Arduino to the sensors that we have and the different resistors. And we'll go through that. We're going to need some resistors. So this is a huge pack of resistors for 13 bucks. It's got more than enough. This will last you a lifetime. There's about 300 resistors in here of various sizes, and we'll go through and we'll use all those. So, or not all of them, but we'll go through and use like 10 of them. We want to make sure that we have what we need, so it's pretty cheap. And then these transistors, we only need the 2N22222s there. We really only need these. But, I mean, it's an $8 pack, and it comes with a bunch of them. So it comes with 25 pieces of those. We only need 2 of them, but $9. You can order those separately if you want. It's just easier to order the entire pack. Then a honestly pretty crappy SD. I don't care how long it takes to really boot up. That's really what this is going to help, is the boot up. And some people may be like, oh, 10 to 15 seconds is too long for a boot up for me. Then you definitely want to go with maybe a solid state drive or an NVMe. Those will really help with boot up. Maybe get it down to about 5 seconds or so. I'm not concerned with that. It's not like you can't drive the car in those 15 seconds, and furthermore, mine's a track car, so when I do drive it on the street, I let it warm up for a good 3 to 4 minutes before I'm driving it, so 15 seconds is nothing. Next would be a cable for a printer, and basically this is an Arduino cable. It comes with one already. However, we want to keep that one for data and connecting to the computer that we have that we're loading the code onto. This is going to be a separate one, a 6-footer one, just so if you want to put the Arduino far away from the Pi. And we're going to use this just for data. So what we're going to do is this cable's only $6. We're going to kind of cut it open, take out the red wire, just snip the red wire that provides power, because again, we don't want power from the USB coming from the Pi to the Arduino. We just want data being sent over. So That's what we're going to do there. And then this power distribution board. This makes it really easy to connect a bunch of wires. So as opposed to, there's a lot of wires that need 5 volts or ground, and as opposed to one long wire that you're just like keep on soldering more and more ends onto, we can use this instead and just plug a 5 volt at the end and a ground at the end, and then each side is 5 volts or each side is ground. Makes it really easy. And then some optional stuff. This is a breakout board. This is it kind of attaches to the top. I guess it's appropriately named a breakout board. You put it on top of the Arduino, and then you can kind of put those jumper pins in here and then screw them down. That's currently my setup now. I will eventually maybe solder this in, but for the most part, this makes it easier to just shove those jumper pins in, screw them down, and they're going to stay there they're not going to move, they're not going to fall out. It's just something easier to work with there. This is the Pi 5 wall cable. So we are going to be powering the Pi obviously from the card, but if you want to bench test the Pi, you need this specific cable, so that way you can power the Pi from your wall outlet and you can see what's going on with it there. And then just some 22 gauge wire. So you don't really need, you may have wire lying around, you don't need a lot of it, but it's good to have it. So I wouldn't buy a lot of it, maybe just 10 feet of pick a color and get that, or if you want to color code it a little bit better, you can buy multiple colors, but again, not really needed. With all this stuff, we're looking at about 196 for the items that are specifically needed, and then a little bit more. Obviously, we're almost knocking on 250's door with this optional stuff. So pretty cheap all around. I would just maybe shell out the 250 and get everything that's optional, because this is already pretty cheap, and then kind of go from there. Okay, so the first thing you want to do is go to the GitHub repo that I posted into the description. This contains the files and the images that you're going to need to proceed with this project. The couple things you'll notice: first, the README has full instructions. Everything that I'm going over here on this video, you can kind of follow along in that README. The first thing is the digital dash image here. So basically what I did was I downloaded a Diet Pi OS image, and then I loaded Tuner Studio Dash, Java, created the auto start functionality to make it boot up directly to TS Dash. All of that is in this image that I then backed up and put here. So if you take this image file, download it, put it on an SD card, you will be 95% up on the Raspberry Pi, where all you do is just turn on the Raspberry Pi, it'll auto boot into Tuner Studio Dash in about 10 to 15 seconds. Next thing we want to do is download this Raspberry Pi imager, and just download it for your OS. Once you do that, install it, and then let's open it up. First thing you'll see is it has you select your device. Again, I strongly recommend a Raspberry Pi 5 on this. The Raspberry Pi 5, just a faster processor. You can use other versions of the Raspberry Pi. However, it may not be as quick depending on your sources. If you're using canbus or if you're not. We're using Serial, we're not using canbus here obviously, but we want to keep it fluid, so the Raspberry Pi 5 is the best option. Click on that. And then it's going to ask you to choose your operating system. And this is where we'll scroll down to using our custom image. We're going to scroll all the way to the bottom, hit use custom, then we'll find that image, that image.xz. You can go ahead and open it. It'll show it as a local 813 megabyte file. Go ahead and hit next. Select your storage. I don't have anything plugged in here, but you would just select your storage and then hit next, and it would write. And that is the extent of it. So pretty easy. Then after you're done with that, all you would do is plug it into take the SD card out, eject it, plug it into your Raspberry Pi, and once the Raspberry Pi powers on, it would boot after about 10 seconds directly into Tuner Studio Dash. If you don't want to use my specific OS or the image that I provided, you can use whatever software that you'd like. So this utilizes Tuner Studio Dash, so you're going to need at least this config file to get everything going. And we'll go into Tuner Studio Dash as well in just a second. So this config file baked into this image file already, you don't need it if you're just using this image file. Okay, so here I have TS-Pro. And as I said, that image file that I made for you with TS- already loaded onto it, that auto boots for you, is all set up. However, it is the trial version. So I'm not sure how long after or how long you can use that before it expires. However, it doesn't have some functionality that you may want. and TS Tach Pro does. It's $39 as you can see here. It's a one-time registration fee. I believe one time for $39 is allows you to put this on 3 separate devices. So I'm not saying share it with friends, but you could put it on 3 separate devices if you wanted to for $39. The reason I bring this up is because the dashboard designer, custom dashes that you would probably want to make that may deviate from a dash that I have set up. Mine's pretty bare bones. Again, this is a track car. You would need this to do so. And speaking of dashes that you can set up and the kind of creative stuff that you can go through, once you get TS Dash Pro to load those dashes or to get examples for those dashes, there is a website called Tuner Studio Dashboards. And it contains dashboards that are all free that you can download and plug in. And with the Arduino code that I've set up, these will all work. So we have, different digital dashes, analog gauges, Audi-like gauges, Ferrari-like setups. These are examples of dashes that people have made that have posted online for free. So you can just hit download, open that dash, and then it'll work for you on your setup. Or there's image packs, borders, and speedometers, and gauges, and needles, and you can make your own. So a lot of people may want to deviate and make their own kind of digital dash setup. Again, the one I have set up is pretty bare bones. It's perfect for what I need, but I understand other people may want a little bit more pretty, we'll say. Maybe they want it a little more pretty. Mine's pretty bare bones. The last file is this INO file, and this is totally separate from the Raspberry Pi. It's about 1,000 lines of code, maybe slightly less. This is the meat and potatoes of this build. So before this, Tuner Studio Dash that has existed for at least 5 or 10 years. So this Tuner Studio Dash has been around for a while, the ability to create your own dash. However, you needed either canbus, and even then it was hard, but more importantly, standalone. So some form of standalone, specifically Speedo, which is kind of a Arduino-based ECU that people would use, and then you could use Tuner Studio Dash and have these custom dashes. This code that I have here basically uses the Arduino and kind of, instead of using it as an ECU, uses just a sensor sending to the Raspberry Pi and to Tuner Studio Dash. I would ask that anyone using this code, please do not use this for monetary gain. Again, this didn't take me 10 minutes to write. This didn't take me weeks either. It took me a few days, but still I would prefer if this was left open source and not used to make money. I'm sure I could use this to make money if I wanted to, but that is not my goal for this. My goal is to help people who are, maybe want some of these modifications for their car but don't have a lot of money. I remember, and obviously I still do to this day, but I remember being young and poor and wanting to modify my car and not being able to because I just didn't have the money to do so. This is one of those things that kind of gives you that option. I wish more people would do that, and I understand that a lot of people, when they have something, like let's say I learned how to tune a car, the first thing I wouldn't do is think, how can I make money off of this? But some people do think that way, and I understand that. However, for me, that's not the first way I think of it. We need the Arduino and we need this INO so that way you can hook up any sensors to the Arduino and it'll pass that data to the digital dash. No more standalones, no more canbus, nothing. You just need to initialize the sensors for your specific sensors, whichever ones you're using, and then you can kind of go from there. And we can kind of go over this slowly, this digital dash file, and the stuff that you may need to correct, the stuff that you may not. But at the top here, I put the user config. This is stuff that you will need to possibly edit. I use ProSport gauges, and those ProSport Evo gauges have certain scaling and just voltages and ohms that they expect. And you can, if you have different sensors, you would just plug the sensors into the Arduino, but then change the scaling that I have set here. The first thing is the odometer. As you probably saw on my dash there, I have an odometer set. This is how many miles were on my motor. This will save on the Arduino, so I had 2,200 when I made this swap to a digital dash. This will increment after that, so if you have 100,000 miles on your car, you would just change this number to 100,000 and then leave it, and it'll increment from there. You don't need to do anything else. This other stuff you don't really need to worry about. Those are just kind of smoothing, if you will, for these gauges. If you notice any problems with smoothing or with kind of choppiness with your gauges, like maybe it's jumping as opposed to just going from one number cleanly to another, then you would play with this, but this should be set up perfectly to what you need now. This is an example of the pressure sensors. So you have a pressure sensor that's 0 to 5 volts. 0.5 is where it kind of starts, and 4.5 is where it would end. And then the pressure max for like a, what does 4.5 volts equal is right here. And you might say, where did you get these numbers? This is kind of crazy. I don't know what any of this means. It's pretty easy, and I have open here the premium oil fuel pressure sender. This is what ProSport uses. A lot of these vendors use pretty much the exact same gauges or sensors and have the same scaling, but you can check your scaling, and you'll see here they give the readout for the linear scale. So literally it's 0 to 45, 0 psi to 145, and then the voltage for 0 psi is 0.5, and the voltage for 145 is 45, and then everything in between. So pretty straightforward there. You would just kind of plug those numbers in. If yours was, say, a 100 psi sensor, you would change this number to 100 psi and kind of go from there. So that's for oil and pressure, or excuse me, that is for oil and fuel pressure. All of that is set up right here. Change those numbers to like kind of fit your use case, but more than likely, these numbers are going to stay the same because it's probably going to be a 5-volt sensor, but this may change to maybe 160 psi or 100, depending on what your sensor goes up to. That's the only number that you would need to change. The next one is the boost sender. So the boost sender, again, we're plugging in just, again, the scaling. So 0.02 volts would equal negative 14.5 psi, and then going to the max, 4 volts would equal 43.51 psi. And where did I get these numbers? Again, this is just literally just taking from this scale right here for this sender. You can see 4 volts, 43, 0.02, negative 14.5. Just take those numbers and kind of plop them in. A lot of these senders and sensors are the same. You probably won't need to change these, but I'm just letting you know where you would. So right there is where you would go ahead and change these. The rest of these numbers you may have to play with, but for the most part you don't. Mine specifically, this is 0 trim psi. This is how much it was off with this scaling. Like apparently these senders are used for many different gauges, and ProSport will actually take a little bit of trimming, like 8 psi as a matter of fact, and trim that. So you may need to add a calibration to yours if it's showing up at the wrong psi. Maybe start this out at 0, see what it reads with like key on, engine off. If it's 0, then you're good, but if it reads at like maybe negative 8 psi when you're literally key on, engine off, then do what I did, change it to 8, and then you're good to go from there. Next thing, temperature sensors. So going down the line, same thing. So this may look familiar. This is just, again, that linear setup, that linear scale setup. The exact same thing for the ohms of 316. We have Fahrenheit of 302, 5,830, and 104. And if you go back to the code, it's exactly the same thing. So again, we have the list of Fahrenheit temperatures up here, and then the ohms that are expected down here. Then we have the floor and the ceiling. Basically, we don't want, I put in specifically, I don't care when my gauge is reading below 100 degrees Fahrenheit. These typically won't do it anyway. Like you can see here, it's not going to really read below 100. You could make it if you wanted to, but I put 100 and then 302. If any temps are near 302, we're in terrible shape. So the ceiling that I put is 300 for now. So those are the easier kind of, and obviously we have to wire these in. It's not just as simple as plugging those numbers into my code and then you're done. These other sensors, or these other gauges we need to accommodate for, are the fuel level, the RPM, and the VSS, or the speed sensor. And this code here is right now set up for a Subaru, basically an 02 to 07 WRX or STI, but it'll work for basically any Subaru from 07 back, 93 to 07, any variant. If you do not have a Subaru, which a lot of people I think that may be using this or trying to make this will come about or will not have a Subaru, There's not a lot you need to change, but there is going to be some things you need to change here, like specifically the pulses per rev. So for an RPM, you may not, depending on what your crank sensor does or how it passes data, it may not be 2, it may be 4, it may be 6. You're going to need to go ahead and change that. Your max RPM, this is just the red line that you could possibly expect. My currently revs out to really 8,500, but I put 9,000 in here just to err on the side of caution. You can go ahead and do the same thing. And then you can play around with some of these other numbers. So basically I kind of reject noise below a certain pulse level. There's different things to kind of smooth the RPMs, and you saw the example of the RPM going up and me blipping the throttle and it working perfectly. This took a lot of going back and forth just for the RPMs alone, so you'll want to need to play with that. For fuel level, I only connect to one wire, and that's pretty easy. It's based off the empty ohms that I can pretty much expect. Your fuel level may change. What I can suggest is for all of these fuel levels, RPM, vehicle speed, is that you plug these code just right in, connect to your RPM and your speed sensor and your fuel level wire, and then see where it comes out. Then you can go through and play with the code based off of that. If you have any questions, obviously feel free to put something in the comment section. I try to keep this code as reusable as possible, so you can just change a few things. You won't have to go through the bottom where it's like about 1,000 lines of code. You shouldn't have to change any of that. You should just have to change the variables at the top to get things working accordingly for you. VSS was probably the hardest, if I'm being honest, just getting the speed down, because it was kind of a little bit different than RPM, and there was a little bit of spiking going on. So you may see some differences here, and you may have to correct some things, but all of it's pretty nicely laid out, and it's just a few variable changes here or there. I don't want to go too far into depth on that, but you should be able to do that pretty easily. The other thing, if you scroll down here, I have all the pins laid out, and this is specifically for the code, but also for your purposes as well, so you know where to put these pins. Oil pressure, fuel pressure, coolant, oil temp, boost, fuel level, and then the digital ones, which are the RPM and VSS. And then I added these in. I don't use them right now, but this is if you wanted to eventually add, if you have in your dash setup. I do not, because I don't care. This is a track car, but a turn left, turn right, high beam, handbrake, and then the check engine light, I'm going to put a separate kind of LED off to the side, kind of a bright LED, so I know what's going on there. But if you want to add that, I kind of define those there. So all those values are set up and defined for you. You shouldn't have to change anything there. Again, the brunt of what you'll be changing, if you're changing anything, I strongly suggest that you just plug this in and see how it works first, are these numbers right here. Okay, the last thing that you're going to need from the computer side, and then we'll start playing with the car actually, is the Arduino IDE software. And basically this allows you to take that INO code that I wrote and upload it to the Arduino and change the code if you want and kind of play with it. So just go to this website, I'll provide it in the description, and then you're going to go ahead and click download for whatever OS you're using, and then go ahead and open it up. And if we open that, so when the IDE opens after you have downloaded it, it'll look like this. We will go ahead and file open. Just open up what we just downloaded, and we'll have that here. And all you have to do is plug in your Arduino. Your Arduino is going to come with a USB that looks kind of like this. One side goes to the Arduino, and one side goes into your USB. Plug that in. It'll be recognized here. You'll be able to select it. I don't have it plugged in right now, but you'll select it as just Arduino, whichever port you have. And then I checked to make sure the code compiles, and then you just hit the upload button and it'll upload to the Arduino, and that's the last step that you need to do. Very quick and easy. If you want to make changes, obviously you have to re-upload that code each time you do it, but the Arduino, when it's powered on, will be constantly running this code from thereafter after you upload the code. Okay. So now we're ready to start putting everything together, right? So let's start with the Raspberry Pi side of things. This is the easier side. I don't have to go too far in depth on this. If you're starting this project, you probably are aware what it entails to power up a Raspberry Pi with a screen and the various things. It's not that complex. So we have the Raspberry Pi here. We put that SD card in. Well, actually, you're going to wait if you're putting a case on, but I strongly suggest that you put a case on your Pi. So this is a 3D printed just case, just to keep it from being like exposed. Obviously there's pins and all kinds of things that could bend or possibly break. So just put it in a case. You can either buy one or 3D print one. They're really cheap. So that's the first thing I do there. Then you have the touch screen here. So if you order the touch screen that I suggested, this is just a 7-inch touch screen, pretty cheap. 2 connections here, well actually 3, but one isn't used. HDMI, and then 2 USB or I think it's mini USBs, and then a switch back here for the backlight. Just keep that on, otherwise you won't be able to see anything. So it comes with the cables that we need as well. So we have HDMI cable, which is what's going to go into the back of that, and then an adapter from HDMI to micro or mini HDMI to plug in to the Pi. So you just literally put this on this end, plug one end into the touchscreen, plug the other end into the Pi, and then the last thing is, like we just saw, the USB. It says the Raspberry Pi has many USB ports, and you just plug one end into the Pi and the other end into the touchscreen, and then you're all set up with this setup. We just need a power. You can bench test it. I told you where to buy that cable, but if you're not bench testing it and you're going to have to do this anyway, is using this 12 volt to 5 volt converter. One end goes into the Pi, the power source. So it's right next to these HDMI ports, these micro HDMI ports right there. And then these 2 wires, pretty easy. You can't really screw this up. Red is 12 volts and black is ground. Feel free to hook that up wherever you want. I do not hook that up to the ignition switch, so some people may want that so that the Pi and the touchscreen and the dash turns on when you power up the car. I like it on a separate switch to turn on and off, so I can have it on when there's no key in the ignition if I don't want. Just I was obviously building this, so I didn't want to turn the car on every time I did it too, but it's easier for me to turn it on and off that way. Plus I can turn it on, the dash on, before I even start the car. It's up to you how you want to wire that. I'm not going to show you how to wire that. That's up to you. It just needs power, again, 12 volt and ground, and then plug that into the Pi and you are all set. So that is the Pi setup. Quick and easy. That's not the big thing here. The meat and potatoes is obviously the Arduino and the wiring thereafter. So let's go into that. Okay, so here we have the Arduino and the potential pieces that you're going to be using. This is the Arduino. This is dead. This is a dead one. I'm not going to use the ones in the car right now hooked up, and it will take me a while to get everything unhooked and back together. So I'm just going to show examples here. I bought this in a 2-pack, so I have an extra kind of distribution board. And then for powering it, again, you can power through the Pi just by using, if you just use the USB cable that comes with it, it'll send power and data through this same cable. However, there is also a separate data or power connection here, and what you can do is with that second 12 volt to 5 volt converter we bought, we could actually power it that way. We would just need some sort of connection, and I bought this. Basically what I did, this is just a plug that would fit into that adapter. You just gotta I just cut that here, and then I cut the USB off the end here and basically made it in like that. So basically the power from this 5 volt converter is going directly to the actual Arduino. That is how we power it. You can power it through the USB if you just want to test it or just see how it's going, but I would power it by its own eventually. Okay, so now we have this distribution board, and the reason we use this is because if we look on the side of this, hold on, let me get this to zoom, we can see the pins on the side. They're all labeled what they are. You can see the analog side is what we're going to be using the most, but there also is a power side. And that power side we're going to be using quite a bit. So we need that 5 volt and that ground setup. So we're going to power it through here or the USB, and then we're going to utilize these 5 volt and ground signals. So we're going to have a bunch of sensors and stuff and pull-ups and all kinds of things that go to that. So we, instead of actually shoving just one wire in there and having 80 branch off of that one wire, what we will do instead is we have this distribution board here, and what we will do is one side we will make entirely positive, which is the red here, and then one side we will make entirely, so 5 volt on this side and then ground on this side. And all we'll do is just take the pins. Obviously you should have a breakout board, the green one that I have in the description, but you will take the white and put that into the ground section there, and then the red and plug that into the 5 volt section there. Again, the breakout board would make that screw in so it wouldn't move just like these are, but that's the initial setup of this. So now all 5 volts all ground on one side. Let's go through each individual sensor and I'll show you how to hook those up so we can kind of go from there. Okay. To keep it simple, we're going to start with the pressure gauge and I'm going to show you exactly how to wire this up. I used tape and a diagram here, a printout of the actual sensor side of the wiring so you actually know where everything is. You're probably going to have a harness coming from your actual sensor, but this is what the actual output of the sensor is and what each wire actually does. So this bottom one is always on 3-prong analog sensors. 9 times out of 10 is going to be your ground. This one up here is going to be your signal, and then this one right here is going to be your power. Now, how would we wire that to the Arduino and to this power distribution block? Well, as showed before, we already put the white here going to the ground, right? So the white, this entire side is ground. So I took the orange ground cable, put that in there to the ground, right? Power, pretty self-explanatory, coming to the other side because the red side is 5 volts. Orange or yellow is going to power. And then lastly is signal. And the signal is what the pressure sensor is going to output to the Arduino. And that is dependent on our pinout setup. So you can look through the code. At the top of the code, I have what each pin does. But A0 is the pin for oil pressure. So if this were oil pressure, we would put it in A0. If this were the fuel pressure, we would put it in A1. A1 is the fuel pressure signal. And that's how it knows that the signal coming in is from the fuel pressure or oil pressure. Pretty easy. The pressure ones are probably the easiest ones to set up. They take a very, very short amount of time, again, because you're just taking the existing harness and just extending the pins out and attaching those to this block here. So you would have 2 here, one for oil pressure and one for fuel pressure, both going into this rail. And that's pressure for you. Let's go on to temperature next. Okay, so now the temperature sensors, a little bit more complex, but nothing too crazy. This is going to be the back of the temperature sensor. Again, there will be a harness coming out of this. You won't have to make your own harness because obviously you have gauges, they come with it, or the sensor itself came with a harness that went into the sensor. But 2-prong analog sensors are going to have a ground and a signal. So the ground right here, pretty self-explanatory. Just so you're aware, you can wire this either way. It's not like one's ground and one's signal. It can go either way. It doesn't matter because we're checking the resistance on the way back. Typically though, if you want to just use the side with the black wire as the ground, that's what you can use. So one side, ground, again, directly to the ground, which would go on this board right here, the ground side. And then the signal side is a little bit more complex. And the reason it is because we're actually providing a 5-volt, what's called pull-up. And what this is we're using a 1K resistor and this wire right here going to the 5K side or the power side of this actual board again, the distribution block. And we're providing 5 volts. Then we resist that to 1K here. And then that signal that's coming down here, we're actually in the middle of it. So we're basically teeing this off right here to before it gets to the pin that we're providing in the actual Arduino, we're putting that 1K resistor in. So this diagram is perfect. It's going to go right here, tee into this, not on this side. It's going to be on this side of the resistor. So again, 5K, resist it, which is with that little piece right there. And then obviously we're going to tee in there. You will need to, I soldered these. You can get away without soldering them, but I strongly advise that you do solder them. It'll make the connection so much more solid and better, and you don't have to worry about, it coming apart or breaking. It's better to solder it. Everything is laid out here. If you want to just pause it and look at this real quick, it says to A2 or A3, and that means A2 or A3 on this board. So A2 is going to be your coolant temperature, and A3 is your oil temp as laid out in the actual code. You can see that again in the code. I'll put that on the screen here as well, what all the pins are. So I'm not just arbitrarily shoving these in. A2 is coolant, A3 is oil temp. So that way when you see it on tuner dash, you'll know which is which. So one of these will be wired to A2. Again, this entire wiring setup will go to A2, and then another entire wire setup like this will go to A3. And that is your temperature sensors. Pretty easy to set up as well. Let's go into the boost sensor next. A little bit more work, but not too much. Okay, and here we have the boost sensor sender now. Slightly different than the oil or fuel pressure, but not too much. The only difference is, again, We don't have to go too far into depth. You saw I did the oil pressure and fuel pressure. Again, signal is going to be the orange. That's going to go to A4 here. So we're going to go to A4. That's the pin designated that I have designated on the Arduino for boost or map pressure. So again, A4 goes there. White here goes to ground. Again, ground on the distribution box, not complex. The difference here is the power signal. So on some, specifically the Pro Sport ones that I use, they are 12 volt. So you can't hook it into the power box there that you get 5 volts from, because that won't be enough. It took me a while to figure that out. I was giving it 5 volts. Boost was always way too low, and I was wondering what was going on. It was because I needed to supply 12 volts to that. That's how you actually supply these. So this power, instead of going to the Arduino board at all, you're going to give it 12 volts from somewhere in the car, the ignition switch somewhere, but it needs 12 volts, at least for this boost sensor. And that is it for the boost. Okay, are you ready for hard mode now? So this is how you wire the digital inputs, and this is going to be for your tachometer and your speedometer. So this is an enlarged view of this transistor here. It's pretty small, but you can see the enlarged view here. The way that you know which pin is which, 1, 2, and 3, emitter, base, and collector, is by this flat side. So this may look like it's perfectly round, but it has a flat end to it, and that's how you can tell which pin is which. And I'll go over how we set this up. Again, this is where I strongly recommend you solder, because this does get rather complex, and if you're just like kind of wrapping these together, it could come loose pretty easy, and you don't want that to happen for you. So the first is the emitter, which is pin 1 here, and you can see I have this taped to a ground. It's literally going right to ground. That's all you do with pin 1. That one's super easy. It just gets harder from there. Pin 2 is the middle pin. That's our base pin. The first coming into that is going to be our signal. So our signal coming from the Tach wire or the speedometer wire, the VSS wire. That's going to be coming in from this purple side, we'll say, into a 100K resistor. I have this labeled 100K. These are 100K resistors right here. This is 100K coming from whichever signal you have. And then another 100K here going to ground. So this is all going to 2, pin number 2. It looks like it's going to 3, but no, this is both of these are going to 2. 100K, 100K, signal, and then ground. This is kind of keep it from floating here is what this does. And then the last pin, the collector number 3, has a 10K resistor, and it's going to 5K. It's going to 5K. This is kind of a pull-up for this specific, for just kind of like a helper. And then the other part of pin 3 goes to D2 or D3. So both of these have 2 wires coming out of, or 2 separate kind of entities, if you will. D2 to D3 are the digital inputs on your Arduino. So do not confuse the digital and the analog. So analog is on one side, will clearly say analog on it, and digital is on this side. D2 and D3 are the ones that we're going to be using. D2 is for the tachometer, or that's how I have it coded in my code, and D3 is for the speedometer. So make sure you're soldering here. Examine this picture real quick. Again, this is as complex as it gets. Okay, so for the people doing this on an 02 to 07 Subaru, to make this easier, I have this wiring diagram and I laid it out. Really self-explanatory. This is for the gauge cluster, the wiring diagram. You can use the A5 and A2 pins because you're taking the cluster out. You're not using those pins anymore. A5 goes to the tachometer and A2 goes to the speedometer. The A block there's going to be 3 green connectors that go into your actual cluster. Obviously, you're not going to be using those anymore. The A one is the far right one, and it's only going to have like 10 pins. So the 5th one is going to be like the middle, and then A2 you're going to see from the other side. You can look that up. It's pretty self-explanatory, but that's a quick demonstration of the signal that you're going to be providing to that 2N2222 there. Okay, last but not least, another simple one, kind of, if you can call it that, is the fuel level. And this is what's going to the A5 pin on the Arduino. Again, the digital or the analog side. This is the analog side, the last one. You can follow this down. This comes from your fuel level. So I actually, on the Subaru, I actually went from the wire all the way back by the fuel tank. It's 1 wire. You're going to route it and it goes all the way to the A5. However, it's going to T in the middle with this 330, not 330K, 330 ohm resistor. So we have just a 330 resistor here, and then this is actually going to 5 volts. So this is a pull up. What these T's do is basically pull that voltage up. That's what we want it to do, to kind of bring it in line to where it should be. So if you didn't have that, it would not read correctly. But yeah, we're gonna tee off right there, and that's a pretty self-explanatory. The wire that you're gonna be using for that fuel level, if you're on a Subaru, hint, hint, it's going to be in the back. It's going to be a brown and white wire coming out of the connector to the actual fuel tank. So it should be underneath your seat. It's pretty easy to spot, but I can go into more depth on that or show pictures of that. If anyone needs help, you can just put it in the comments. Okay, so when you are done, it'll look something like this monstrosity. And obviously we need to clean this up quite a bit. There's a lot of different wires going to a lot of different places. It's kind of a rat's nest. However, I wanted to get this online as quickly as possible. I will clean this up. This needs to be obviously tidied up quite a bit. You can still see all the labels I have for everything and just the sea of wires. But it all functions as it should. We can see the dash here. I will provide a print file that I made for this specific model. This is an 02 to 07 kind of gauge clustered 7-inch screen mount, and you can, I'll provide it for free, I don't care. Let's go ahead and power it up though, and then we'll see what happens when we boot, and then you can kind of get the same thing here, but it's really self-explanatory from that point on, just hooking everything up. I'm not going to tell you how to put it into your car because you may have a different dash setup. You may want to do it a different way than I did it. So let's boot this thing up and let's see what she looks like. And that is the digital dash. So you can see right now, because of the car's not on, I don't know if you have the key in, but the odometer is working where it should. Again, we started with 22,000 or 2200, as you remember from my code there. The temperature gauges right at 104 because they bottom out kind of at 100. It shows my fuel level appropriately. Obviously zero fuel pressure, zero oil pressure, and boost is, it shows negative 21 because there's not any power going to that sender. Remember, we need to provide 12 volts to the actual boost sender, and I do that once I turn the key. I don't provide it all the time. But as you can see, works great here. Let's go ahead and turn it on. Okay, so this is car on. Give it some gas. Everything looking great. I want to rev it a lot when it's really cold. Okay, so we'll turn it off here. And I just wanted to say what I've set up on the dash as well, if you use the image that I provided, is that I set up, if you want to make it so it turns off, you know, not by the ignition, but rather by a switch, that red one is the one that turns it off, the power, you have to shut down successfully. Please do not just power off the Pi. If you do that, you will break something. So what's cool about this is if I touch this fuel level right here, because it's a touch screen, it'll shut down the Pi. So if I just touch right there, you can see it shut down. Pretty cool stuff, and then I'll just hit this red button, and then everything's powered down. Okay, so a quick rundown of Tuner Studio Dash. When you load the dash up for the first time, if you're using my image, or if you're not, mine will look similar to this. There'll be obviously a few more parameters, but I wanted to kind of walk you through Tuner Studio Dash. It's not too complex, but there's a lot of customization that you can do, a lot of warnings you can set, things of that sort. Again, I strongly advise that you buy TS Dash Pro so you have all these options available for the entirety of your usage. But so let's say we have this dash here. First thing is, let's say we want to add a warning to one or move it around. First thing we need to do is go to designer mode. So designer mode allows you to take these and move them wherever you want. Make them bigger, make them smaller. And the bigger thing is we can go to the dashboard designer, go to the properties dialog, as you can see here. We can define the output channel, so that's basically what we're outputting from the Arduino to the actual TS Dash. We can assign that here, and then also change the low warning, and high critical level. So this will turn yellow when it's 200, this will turn red when it's 245. can come in handy if you like those alerts coming at you, and you can set the low side too, and you can set the max and min values here. A lot of customization. You can even change the labels, make it say boost if you want, all kinds of stuff. So that's pretty cool for there. The other thing I would suggest if you're doing this on a Raspberry Pi 5 is turning anti-aliasing off. Turn that off. It'll make it refresh a whole lot quicker. It won't be as laggy. So make sure you turn that off for using this on a Raspberry Pi. Another thing, let's get out of designer mode here, is you'll see these arrows. These arrows are available. This is why a touchscreen comes in handy. You can kind of scroll up and you can access this menu here. So if you're going to not use what I gave you, which I imagine most people may not like, it may not be exactly what they want, you'd want to make a new project. So basically what you can do is you can go, the project management page will have this open projects dialog, and you can go ahead and make a new project. Start with another one if you want, but either way, once you do, you can select it, and then, like, let's say this one right here, and then we can go ahead and open it. So you can see when something's red like this with an arrow across through it, that just means that the output channel is not correct. So if I go to Dashboard Designer, Properties Dialog, and then I go to the output channel, you can see there's nothing set. So if I set this to, let's say, VSS, you can see the red goes away. It goes away, and now it's ready to be used. This is another example dash. If you want to use another dashboard, one that you've downloaded, this is how you would do it. So you go to Load Dashboard. Again, let's say that's the default. We go to Other here, click into where those dashes are. So if I go to my documents here, should have one called dashes. Yeah, here we go. So let's say I want to do the Supra dash. There's one that mimics a Supra. The new Supra, I can just go to Accept there, and there we have it. So some people may like this dash more. Again, you're going to have to go through with the designer, set these outputs to what they're supposed to be in the properties dialog, not the color dialog, but the properties dialog. I'll just set 1 so you can see it again. Again, there's no output channel set. We need to set it to what we have. Set it to the vehicle speed sensor. It doesn't matter. As long as you have it set to the correct one, it doesn't have to be the correct one. How long as you have it set to something, it will be showing appropriately. The other thing I wanted to allude to is, again, I'll turn off anti-aliasing. The other thing I wanted to allude to is if you double click on this, you will get this kind of opening here, and you can do the same thing on the touch screen. If you double tap the touch screen, you'll get this. And this comes in handy because if you make some changes to the INI file, not the INO file is the file that goes in the Arduino, the INI file is how the TS dash kind of takes those signals and uses them. So if we go to vehicle projects and then go to project properties, you can see here under firmware, we select other. And then if I go to other, I can go to I can go to my downloads, and then all the way at the bottom, that's my INI file. I can open that. And once I open that, it should take a second to populate, but it's associated directly with my specific dash. You would have to change those outputs, but you want to make sure that you have those files in there. You have to associate that INI file with Tuner Studio Dash because that's what the Arduino is sending right now. Okay, and I just want to show the INI file that I made here. I just called it Speeduino Travis. That signature is important on line 9. That signature is the exact signature coming from the Arduino as well. Do not touch that, or if you do, change it in both spots. I just strongly advise you just don't touch it. Basically, I call this Speeduino Travis because it's sending a whole, or it's configured for an entire ECU. That way Tuner Studio can pick it up without issue. If you just configure the output channels, then you will have problems. But let's go down to the output channels just so you can see. This is the block that is the most important, and this is what, when you assign those output channels on Tuner Studio Dash, this is what you're calling. So RPM is right here, oil, that's temperature analog and coolant analog. Then there's map raw, oil pressure, fuel pressure. VSS is vehicle speed, but that is in kilometers per hour. It will convert though. If you do a mile per hour gauge and use the VSS, it will do a conversion by itself from kilometers per hour to miles per hour. Fuel level, and then you have your left turn signal, right turn signal, so on and so forth. You can add to this right here. All these right here are just kind of how it derives. These aren't really used so much per se. Well, these are, but some calculations are done. If you want to add to the Arduino and what it's sending, then you would also have to add it here. That's very important to add it here, else the Tuner Studio Dash will not pick it up. However, this does have pretty much everything. I may add other things in the future, and if I do add to it in the future, I will just update that GitHub repo. So I will update the INO file or the INI file with the appropriate changes. And if you have some changes that you suggest or that you want, again, I'm trying to keep this open source, and I will do it in my spare time too. So let me know if you want me to add anything to it, or you found an issue or a bug. Just keep me posted, and I will add to this. But I appreciate you all watching, and please like and subscribe.